So, I want you to picture something. Right now, somewhere in a quiet New Jersey town, there's a mayor sitting at a desk looking at a proposal for an artificial intelligence data center.
Yeah, and it's probably a massive stack of blueprints.
Exactly. And the schematics, I mean, they detail a facility that requires as much water as a small city
Hmm.
and as much raw electricity as like a nuclear reactor.
It's staggering.
It really is. And, the narrative we've been sold for a decade is that our digital lives exist in this weightless, invisible realm, right? We just call it the cloud.
The cloud. It sounds so lightweight.
Right. But looking at these blueprints, the cloud isn't in the sky anymore. It's grinding against the physical Earth. And, well, the Earth is starting to push back.
Yeah, and that friction, that physical pushback, is actually the defining characteristic of this current moment in tech.
Which brings us to our mission for this deep dive.
Right.
Today, we're unpacking a really fascinating stack of structural analysis reports and global news dispatches. They're all dated around May 21st, 2026.
And they all point to the exact same thing.
Yeah, we are going to connect the dots between AI, energy, water, global shipping, and ultimately your local city.
Because the central theme of today's sources is that AI is no longer a lightweight information industry. It just isn't. It is rapidly shifting into a heavy physical infrastructure industry.
Like steel manufacturing or something.
Exactly. It's a structural phase shift causing immense friction across the entire globe.
And a quick rule for how we approach these sources. We aren't looking at the news to judge what's, morally right or wrong.
No, not at all.
We look at gradients in fiction, just impartially observing where the pressure in the global system is building up.
And to understand that friction, we first have to look at what AI actually is right now. You have to imagine it not as software, but, well, like you said, like an aluminum smelter.
Okay, let's unpack this. Because we've been hypnotized by the word cloud, thinking our ChatGPT prompts just float in the ether.
Right, like magic.
But underneath, it's actually just massive cooling towers, gigawatts of electricity, and physical land. The magic trick is kind of losing its misdirection.
It really is. What's fascinating here is that AI has transformed from an abstract operating system into a really high-density physical load. It's a thermodynamic engine.
Meaning what, exactly?
Well, almost 100% of the electrical energy pumped into an AI processor is converted directly into heat.
Wow.
So it consumes electricity, produces intelligence, and generates an astronomical amount of thermal waste.
Which totally explains the AION project mentioned in the dispatches.
Oh, the one in France. Yeah.
It's a 10 billion euro AI data center plan.
Yeah.
And the players involved are what stood out to me.
It's not just the big tech companies anymore.
Right. You've got telecom like Orange and Scaleway, but sitting right there with them is EDF.
The French national power company.
Exactly. Power companies are essentially becoming AI players.
And they have to. The bottleneck is no longer just getting the GPUs, the microchips. The real battle is for connection rights.
Connection rights, meaning access to the power grid.
Power, cooling water, high voltage substations, industrial land. You need gigawatt scale electricity.
Which is just a massive amount of power. And the sources point out how this is warping existing markets, like the PJM Regional Transmission Organization on the U.S. East Coast.
The grid managers.
Right. They put out a warning that AI data center demand could drive a 76% surge in electricity prices.
A 76% surge for regular consumers? That is incredibly destabilizing.
Yeah, that's your electric bill almost doubling just because a data center opened nearby.
And if AI is suddenly this heavy industry, we have to ask why it's causing so much chaos so quickly.
Right, why are we seeing these 76% surges?
It's because of a concept called shear, or velocity mismatch.
Shear, like in engineering.
Exactly. It's what happens when different layers of reality move at fundamentally different speeds.
Okay, break down those speeds for me.
So the sources identify specific layers. At the very top, you have the speed of AI investment and software development.
Which is lightning fast.
Right. Capital moves instantly. Software updates in weeks. But that speed is vastly faster than the next layer down, which is grid expansion.
So wait, you're saying the technology and the money are moving at light speed? But like pouring concrete for a substation or getting a permit takes years.
Decades sometimes.
The software is literally outrunning the physical Earth.
That is exactly what is happening. The grid expansion is faster than the institutional speed, the red tape, and that is faster than the human living membrane.
The human living membrane. That's a fascinating term, meaning like local communities.
Yeah, how fast communities can actually adapt to having a gigawatt facility dropped in their backyard.
So the friction and the heat we see in the news, it isn't just a glitch.
No, it's the mathematical result of these speed differentials just grinding against each other. It's a continuous synchronization failure.
We're going to keep seeing these compatibility errors between AI growth and physical reality,
Everywhere.
which brings us right back to the local city level,
Yeah.
because that's where this shear hits the hardest, right where you, the listener, actually live.
Right. The local friction.
Going back to Millville, New Jersey, the city recently rejected a massive 1.4 gigawatt AI data center.
1.4 gigawatts. Just for context, that is roughly the output of a commercial nuclear reactor.
Just for one facility. And the reasons for rejection were really interesting. It wasn't just standard, environmental activism.
It was survival.
Yeah, it was a direct conflict over what the reports call the water stress factor.
Because of all that thermal heat we talked about.
Right. They need millions of gallons of cooling water.
Yeah.
So it's the data center versus the local drinking water systems. Plus, there's the noise from the HVAC systems and the immense power burden.
So what does this all mean?
Well, imagine your town is asked to house a massive, loud, thirsty engine that powers a spaceship you aren't allowed to ride.
That is a great analogy.
That's how these local governments are starting to view AI data centers, because the structural asymmetry is huge.
The benefits all move upward.
Exactly. The profits, the stock valuations, the national AI acceleration, that all goes upward to massive corporations and national governments.
But the brutal infrastructure burdens the strained water, the noise, the lack of actual local jobs that remains entirely local.
So the local towns take all the physical hits.
Which is why we are seeing the beginning of city filtering.
City filtering.
Cities are waking up and realizing they have the power to act as local operating systems. They can just filter these projects out.
Ah, I see.
It's a direct conflict between national AI strategies, which want to build as fast as possible, and local living systems that are saying, no, we need our water.
But it isn't just local water and power holding back AI. The physical hardware itself, the servers, the microchips, they rely on this really fragile global logistics web.
And that web is undergoing its own bizarre transformation.
Yeah, let's look at the Strait of Hormuz. The dispatches note a limited reopening around this time. Chinese and South Korean VLCCs, very large crude carriers, are passing through.
And because the ships are moving, oil prices dropped.
Right, the financial market looks at that and sees a return to normal.
But the sources warn this is a really dangerous illusion.
Yeah, because Hormuz is no longer just a physical shipping corridor. It is transformed into what the reports call a permission OS.
A permission operating system.
Okay, here's where it gets really interesting. A physical body of water is acting like a software firewall.
It's wild to think about.
You don't just sail through anymore. Your ship has to have the right logistics connection rights to pass the firewall.
Because insurance, military control, sanctions, and finance have all merged into a single operational structure. They dictate exactly who is allowed to pass.
But just to play devil's advocate, hasn't maritime shipping always been super bureaucratic?
Sure, there's always been red tape.
Right, port manifests, customs. What makes this a permission OS rather than just traditional geopolitics?
It's the speed and the digital enforcement. It's dynamic now. If a satellite flags your ship, the London insurance market instantly drops your coverage.
Wow.
And without insurance, you mathematically cannot enter major ports. The digital block happens before the physical block.
And I want to clarify here, we are just looking at this impartially. We aren't taking any political sides in the Middle Eastern conflicts. We are strictly observing the logistical reality on the water.
Absolutely.
Yeah.
The reality is that the water itself is conditionalized.
Which is leading to these massive shadow networks.
Mm-hmm.
The U.S. is placing sanctions on evasion networks passing through the UAE and Oman.
It's the rise of a shadow logistics OS.
People are building entirely parallel supply chains just to bypass the firewall.
Because the market is calcifying. The financial markets desperately want to pretend this is normal shipping.
But on the ground or on the water, it's highly strained, heavily controlled transit.
Exactly.
So how does a permission OS in a Middle Eastern strait threaten a massive AI data center in New Jersey or France?
It all connects through the semiconductor supply chain.
The microchips.
Right. We tend to think of a microchip factory as just a building that makes chips, but it's actually highly dependent on a continuous flow of specific raw materials.
Like helium.
Yes. South Korean semiconductor manufacturing has a massive hidden dependency on ultra-pure helium.
Why helium?
They use extreme ultraviolet lithography lasers to print the chips. Those lasers get so hot they turn the material into plasma. You need helium to cool the chamber. because it doesn't freeze or react with the silicon.
And where do they get the helium?
It's extracted as a byproduct of liquefied natural gas, LNG.
Which flows right through the Strait of Hormuz.
Precisely. The reports call this long-distance membrane contact.
Long-distance membrane contact. That's a great visual.
But supply chain isn't a factory. It requires a flawless sequence. Hormuz to LNG to power grids to chemical logistics to helium to South Korean semiconductor manufacturing.
And then finally to the data center in New Jersey.
Right.
So we started by talking about AI as this heavy, power-hungry beast, and now we see its Achilles heel.
It's incredibly fragile.
It's not just about building the microchip factory. If one invisible helium shipment gets stuck in a geopolitical firewall halfway across the world,
the whole AI factory floor grinds to a halt.
the lasers literally overheat.
If we connect this to the bigger picture, the bottleneck of global AI is shifting.
Away from just manufacturing capacity.
Yes. It's shifting to the continuity of connection, whether that logistics membrane remains intact.
Because semiconductors are no longer a factory industry.
No, they are a logistics membrane industry. A single blockage in the permission OS of global shipping ripples straight into the power grids of Europe and the US.
It's all completely interlocked.
It is.
So just to summarize this for you, the listener, the next time you use an AI tool, realize you aren't just pinging the cloud.
You are activating a massive, heavy industry supply chain.
Exactly. A chain that spans from gigawatt substations in New Jersey to complex, highly restricted shipping firewalls in the Middle East. AI has fundamentally become a physical infrastructure problem.
And that leaves us with some core questions from the sources to really ponder.
Right. What are the big takeaways?
Is the real bottleneck for AI the GPUs themselves, or is it pure physical connectivity?
That's a big one.
And will your city compete to attract this massive AI infrastructure, or will it begin filtering it out?
Choosing the local living membrane over national tech dominance.
Exactly. And finally, is the word cloud finally starting to hide the massive physical reality underneath?
I think it definitely is. And, that leads me to a final provocative thought to leave you with.
Okay, let's hear it.
If local human communities continue to reject the massive water and power burdens of these data centers, and we know power companies are becoming AI companies,
Right.
will we soon see the rise of autonomous AI city-states?
Oh, wow.
Like just completely geographically isolated grids built out in the desert or the tundra, purely for power generation and cooling, entirely divorced from human populations.
No humans, just servers and cooling towers.
Exactly. Just machines humming in the dark, miles away from any local living membrane. It's something to think about as this physical phase shift continues. Thank you so much for joining us on this deep dive.